everyone, welcome back to my YouTube channel. This is Sangeeta BJ from Sri Venkateshwara College of Engineering from the Department of Information Science and Engineering for some ECHA section. Today in this video we are going to discuss about the subject mathematics and our topic is calculus. The particular contents we are going to discuss about the topic is introduction, definition of calculus, limits, derivatives, continuity, application of calculus and problem solved. Let's move to our first slide, which is about introduction. Calculus, a branch of mathematics developed by Newton and Leibniz, deals with the study of the rate of change. Calculus math is generally used in mathematical models to obtain optimal solutions. It helps us to understand the changes between the values which are related by a function. Calculus math mainly focused on some important topics such as differentiation, integration, limits, functions, and so on. Calculus mathematics is broadly classified into two types, and they are differential calculus and integral calculus. Definition of calculus. Calculus means the part of maths that deals with the properties of derivatives and integrals of quantities such as area, volume, velocity, acceleration, etc. by processes initially dependent on the summation of infinitesimal differences. It helps in determining the changes between the values that are related to the functions. Limits. The degree of closeness to any value or the approaching term. A limit is normally expressed using the limit formula as limit extends to c f of x equals a. It is read as the limit of f of x as x approaches c equals a. Derivatives. Instantaneous rate of change of a quantity with respect to the other. The derivative of a function is represented as limit extends to h f of x plus h minus f of x all divided by h equals a. Continuity. A function f of x is said to be continuous at a particular point x equals a if the following three conditions are satisfied. F of a is defined, limit extends to a f of x exists, limit extends to a negative f of x equals limit extends to a positive f of x equals f of a. Applications of calculus. Calculus is a mathematical model that helps us to analyze a system to find an optimal solution to predict the future. In real life, concepts of calculus play a major role. Either it is related to solve the area of complicated shapes, safety of vehicles, evaluating survey data for business planning, credit card payment records, or finding the changing conditions of a system affect us, etc. Calculus is a language of physicians, economists, biologists, architects, medical experts, statisticians, and it is often used by them. For example, architects and engineers use concepts of calculus to determine the size and shape of the curves to design bridges, roads, and tunnels, etc. Using calculus, some of the concepts are beautifully modeled, such as birth and death rates, radioactive decay, reaction rates, heat and light, motion, electricity, etc. Let us go through a problem for the clear picture of this concept. Let f of y equals e power y and g of y equals tan y. Use the chain rule to calculate h dash y, where h of y equals f of g of y. Let us go through the solution. The given in the above question is f of y equals e power y and g of y equals tan y. Let us firstly find the first derivatives of the above functions, that is differentiation of e power y with respect to y is e power y, and that is the f dash y, and similarly differentiation of tan y with respect to y is tan, and that is g dash y. And here we need to find h dash y. So h of y equals f of g of y. Similarly, h dash y equals f dash g of y into g dash y. H dash y equals f dash tan y into tan. Here we just replaced the values of h dash y and h of y. By substituting the values, h dash y equals e power 10y into 10 or h dash y equals 10 into e power 10y. So thank you for watching. Please do like, share and subscribe to my YouTube channel.